Hello, this is Professor Urbis White. Today we will talk about doing some word problems related to exponential and logarithmic functions. And I'll show you as many examples as I can at this point. And I'll assume that you know how to solve basic problems, but we're going to put some words to it. One typical problem is the compound interest problem for the exponents. And each letter means something in here. Now, A is future value of P dollars. P is what you put in a bank, for example, and then they compound the interest every some period of time. It all depends what they're doing. And the formula, don't worry about where the formula comes from, is P times 1 plus R over N to the nth power. Now, R is your annual interest rate. Okay? In this particular formula, you have to put it in decimal form. For example, 20% is going to be 0.2. Okay? N is number of compoundings a year. So if they say your account is compounding monthly, N is 12. So for monthly, N is 12. If they say they are compounding it quarterly, it's going to be 4. Okay? And like twice a year, it's going to be 2. Those kind of things. So you need to understand how many compoundings they're doing a year. T is when they ask, okay, how much money do you have at the end of 15 months or 2 years, 3 years? T is that, but you have to put it in years in this particular formula. In other words, for T, if your period is 6 months, you don't put 6, you put 0.5 years. Does it make sense? So you're going to put it in years. So now that we have the formula, because you have an exponential expression in there, let's see how it works out when you have a real life example. All right, here's one. What's the future value of $1,000 compounded quarterly at an interest rate of 1.2% after 2 years? So you put in $1,000 and they compound it quarterly, and at the end of 2 years, how much money is going to be there? Okay, so put down the formula. Now let's look at it. P is what you put in, 1,000. 1 plus, now 1.2% in decimal divided by 100, so it's 0.012. Now quarterly means 4 times a year, so you put the 4 in here. Then you have in the formula N in here as well, 4 times 2. So understand how this works. So when you put it in the calculator, this is what it's going to look like. You're going to have to put 1,000 and then put multiply. And I use the parentheses, put 1 plus. Your calculator knows order of operations. Put 0.012 divided by 4. You don't have to use parentheses because your calculator will know to do the multiplication before it adds. Then close the parentheses. And then maybe in your calculator you have a function that looks like that, y to the x or x to the y, something like that. In most calculators, it is there. Or it may be to the, I call that a caret. And so you can close this, push this button and push 8. Or push this button and push 8. And then sometimes you don't even have to push enter, and then or equal, and then it will display this amount of money. All right, very good. Now, let's do another problem. A deposit of, this is a little harder. A deposit of $3,000 is made and the account earns 8% interest compounded quarterly. Again, quarterly, N equals 4. How long will it be before the account is worth $4,500? In the previous example, I just put in numbers and then I don't know the left-hand side of the equation and it's straightforward. But with this one, I need to do some manipulation. So what we are going to do first, I want to isolate this 4t. How the heck am I going to do that? I can just divide both sides by 3,000 first. And now 4,500 divided by 3,000 is simply 1.5. All right, these two will go. So you have this situation, 1 plus 0.08 divided by 4 to the 14th power. Now, this is the beautiful part. So when you want to solve an exponential function, do you remember what we used to do if the bases do not match? We just take ln of both sides. Very good. So let's do that. ln. Now, I know my ln rules. What happens with the exponent? It goes in front of it. So you write 4t times ln of 1 plus 0.08 divided by 4 is 0.02. And you have ln of 1.5 on the left. Now, I'm supposed to solve for t. So what can I do? I can divide both sides by 4, which is that guy, times ln of 1 plus 0.02 is 1.02. And look what's going to happen. These two will go, and these two will go. But I have to do that on the left-hand side as well. 4 ln of 1.02. And that will give me the t. Okay? When I do this in my calculator, this is how you should do. Look at your calculator. It has a ln button. Just go ln of 1.5, and then push divide. Then put parentheses in here, because you're dividing by the whole thing. Put 4 times ln of 1.02, and close your parentheses. And it's going to give you, I did that ahead of time, 5.12 years. So this problem was not that straightforward because I needed to do some manipulation. So remember, compound interest formula, if you don't know t, take ln of both sides and then solve for that. All right. The next type of problem that you may see is the radioactive decay. Okay? This has to be, all right, radioactive decay, sometimes they give you the half-life, and I just put the formula with the half-life in it. A of t is the amount after t years, or days, or months, and it has to be, matching these guys, okay? Make sure if this is in months, this is in months. This is in year, this is in year, that kind of thing. And this is given, half-life. So half-life means an amount of something that decays. What happens, how much material you have, how much time does it elapse when you reach half of the mass. So 1,000 becomes 500, 2,000 becomes 1,000. How long does it take? That's called half-life. So let's see how this works out. Half-life of plutonium is 24,360 years. Suppose a researcher possesses a 1 gram sample. How long will it take before 0.9 grams is left after t years? All right, let's look at it. This one is a reverse problem as well. Now let's look at it. 0.9 equals 1, what you start with, 1/2 t over half-life. All right, so since half-life is in years, this t is going to end up being the, in years as well. So let's do the ln of both sides trick. All right. So since I have a 1 in here, I don't have to worry about that. So I have, with the ln property, ln of 0.9 equals t over 24,360 times ln of 0.5. All right? Let's go and let's get that. So t is going to be 24,360, all right, times ln of 0.9 divided by ln of 0.5. Okay, So what do you need to do with your calculator? Push 24,360 times. Take ln of 0.9, divide by ln of 0.5. If you don't see this right away, remember what I did is I pretty much did this thing. I can multiply everything by something to get rid of all this. To get rid of ln of 0.5, I have to divide. But I cannot just divide there. I have to divide here as well. And that will do this to it. All right. Now I need to get rid of the 24,360. So what do? I just multiply by that. And I cannot just do it here. I have to do it here. And that will do this. And guess what happened? Now t is by itself, which is 24,360 times ln of 0.9 divided by ln of 0.5. And I did that ahead of time for you. That gives me 3702.8 years. All right. So this is that. Let's do a log problem. So I did a compound interest and radioactive decay. Now, problems with logs. For example, loudness of a sound has a log in it, in its formula. So let's look at what it is. L is loudness in decibels. And then it is, X is the intensity in watts per square meter. Okay, so you put that in here, 10 to the negative 12, and you have a 10 times log of that, that's base 10. And then that's going to give you loudness of a sound in decibels. All right, let's look at it. Normal conversation has an intensity level of 10 to the minus 6. Here we go, level. Oh, here, in this original. 10 to the minus 6, here it is. Watts per square meter. How many decibels is normal conversation? I put 10 to the minus 6 here, okay? And that's going to be, I'm looking for L. This is the function notation. So I simply put L equals 10 times log of 10 minus 6, and this is already in the formula. When you do your exponent manipulation, what's going to happen? These two go, you're going to have a negative 6 in the bottom. And look how it works. You have a negative 6 in the bottom. Since it's negative, you can use the log thing, and that will turn out to be 6, positive 6, times 10, 60 decibels. So let me do this a little bit slowly. Look how that is. That is the tricky part. You can write that as log of. Move this up. When you move it up, it becomes positive, remember? And log and 10, they are inverses of each other, so they cancel out. You're going to end up with positive 6. And you already had the 10, 6 times 10, 60. Now always put your unit next to your answer. All right. Another application of log is pH. Since you use a shampoo every day, you know pH, da-da-da-da. So it is, what is pH? pH is negative log of hydrogen concentration, hydrogen ion concentration in moles per liter. Moles is kind of like amount, so it is the number of grams divided by atomic weight. So don't worry about it, they will give it to you. Example, what's the pH of household ammonia for which, see, it's given, H plus, the hydrogen ion is 10 to the negative 12 moles per liter. If they say nothing, and just assume it's moles per liter, all you have to do is pH, put the formula, negative log of 10 to the negative 12. And I know these two are inverses of each other, so you have negative of negative 12, which is 12. If you have neutral concentration, your pH is going to be 7. You don't want that to be not far off from 7. But if you want it acidic, more acidic stuff in it, that's going to be less than 7. And basic, like ammonia, it's going to be more than 7. All right? So this is pretty basic, ammonia. All right? Okay. The last one that I want to go over is the Richter scale, because we are in the earthquake country. Richter scale is a scale that measures earthquake intensity. Here's some physics information for you. All earthquakes are compared to a zero-level earthquake whose seismographic reading measures 0.01 millimeter at a distance of 100 kilometers from the epicenter. Epicenter is where the earthquake occurs. Here is the example. 1906 San Francisco earthquake has a seismographic reading of 63,096 millimeters, 100 kilometers of its epicenter. What did they just give me? They gave me this. What was the magnitude? They're asking this. And this is the one that you hear, oh, Richter scale of 6, 7. But look at it. This one was very, very high, 7.8. Plug it in. When you do this, you're going to put log of 63,096, divide by 10 to the negative third, and then take the log of that. You're going to end up with 7.8. That is a very strong earthquake.